Hi everyone. Did you know that by 2025, 51% of all of IT global spend will go on public cloud solution? And beside the spend that will increase on public cloud and in cloud in general, we also know that the fact that cloud native technologies or cloud native development is on the rise, with 6.8 million developers are already using cloud native technologies, including containers, Kubernetes, and serverless functions as well. We also know that developers are human after all, and in a recent research, we know that 95% of all cybersecurity breaches are happening due to human error. At the end of the day, someone from the development team or the wider supporting team. The last thing to take into consideration is the fact that today we are developing and deploying faster than ever, and over 1,400 different deploys are being done every year by an average IT company, which stands for 4 deployment a day for a year every day. What it means actually is the fact that we are developing more, right? We're spending more money, we're spending IT budgets on cloud, but we're doing that much faster. So we have less time to check for ourselves, which puts us kind of in a risk, because at the end of the day, everybody is prone to errors. So hi everyone, and welcome to the Cloud on the Horizon. My name is Ori Bandit, and I'm really happy to be here with you. I'm the VP of Product Management at Checkmarx, and we're going to spend the next 15 to 20 minutes talking about what are the challenges that cloud native holds and how, using modern application security approaches, you can mitigate and be prepared for those risks. So what are we going to talk about today? We're going to talk about the challenges of cloud native development. We're then going to talk about a modern approach on how to securely develop your application, your cloud native application. And then we're going to talk about the challenges specifically to a modern approach to AppSec and how we at Checkmarx can solve them. So let's start with the cloud native development challenges. The first challenge that we see is the business need for speed. By the last 5, 10, 15 years, we are running faster than ever. And not because we want to, because we have to, because the business demands, and development team together with AppSec professionals, we have to keep up with this need to make sure that we develop faster than ever. The next challenge is about shifting left and providing developer autonomy. We want to make sure that we incorporate security as early in the cycle as possible, and also giving the developer everything that they need in order to find and remediate the vulnerabilities as they come along. The next challenge is the fact that the repository has become the center of the universe. And if you don't exist in the repository, you don't exist at all, because at the end of the day, nobody wants to switch between the different tools, and it's all about being there as part of the developer ecosystem. I think that Log4j, which was kind of the adventure to finish last year's, made sure that everybody is aware of the risks and the fact that open source is everywhere. You have open source in your toaster, in your watch, and in your car, together with over 80% of your application. And we need to find a way to mitigate the risk and make sure that you are aware and can integrate those third parties in a nice manner. The last thing, and this is more relevant to cloud native than anything else, is what we call everything is code. And everything is code is actually the fact that we see more and more parts of the systems now being saved as code. We see containers, orchestrations, network as code, policy as code, and my top favorite, infrastructure as code. And as those parts of the system move to become regular code, we can and we should scan them and treat them just like any other part of your application. Forrester refers to that as going beyond the traditional definition of code. And I specifically like this quote, which was released last year as part of their application, the Forrester Way for Static Application Security Testing, which was released early 2021. They are talking about the fact that APIs are now becoming common application building blocks. We have citizen developers who are not your tech savvy traditional developers are now using low code to develop applications, and sometimes even full-fledged customer-facing application. We have developers that are using infrastructure as code to define cloud configuration. And Forrester recommendation is to start looking for tools that will scan those new type of code. And we are going to talk about everything that was just mentioned within the next few minutes. On top of everything, we need to remember that the developers, the development team is in the middle of everything. And just think how much responsibility now lies on the shoulders of the developer. They need to write quality, secure code that provides the business logic that they need. They need to do that by incorporating relevant third parties in order to reduce time, and nobody actually wants to write everything on their own. They need to have it configured correctly, whether it's their containers, orchestrators, or anything else. And they also need to have it on the right infrastructure so it will run in an efficient manner on the cloud. They have to do all of that on time with the right quality in a secure manner, because a simple mistake can reach production within a matter of minutes, and then you can have a breach 2 minutes after, and we have seen example of that in the past. Now that we understand the challenges of cloud native development, let's talk about a modern approach to cloud native security and cloud native application testing in particular. One thing that has changed is the fact that security now shifts all the way to the left. And if I were to talk to you 5, 10, 15 years ago, what would happen is that the development cycle would look something like that. Development phase was something in between 3 to 6 months. Then we would have a stabilization phase or a hardening phase for probably another 3 months. And then deployment would take a few weeks, if not months. In addition, each one of these parts would have been conducted by different parts or different departments of the organization. Development would mostly be responsible for the application source code. Deployment would have been done by the DevOps or the central IT, and infrastructure would be owned probably in a centralized manner by a central IT or the infrastructure team. And now what we see is the fact that everything is being shifted in the speed of DevOps into a single stakeholder, which is the developer. And as we already talked, the responsibility that lies on the developers is simply enormous, and they have to be responsible for their application code that consists of open source and application source code, their containers, their orchestrators, and also the infrastructure when they are using infrastructure as code, and everything is being deployed 4, 5, 50 times a day. It really depends on how mature they are. And a single mistake, as I said, can reach production within a matter of minutes. Another evolution that we have seen with the rise of cloud native development is the fact that the traditional approach was probably a huge monolith that had everything inside. We wrote everything. We didn't reuse. It was million lines of code in one single repository. And now what we are seeing is the fact that we are moving into a concept that we like to call Legolizing. And why do we call that Legolizing? Because just like when I'm building my Lego set with my kids, I'm taking a brick here and another brick from there and a figure from another set. This is the way that we are developing software today. We split everything into tiny microservices, anything between 15 to 500 different microservices in an average application. We have them, the containers that are aligned on the level below. APIs, we're using a bunch of external services, whether they are coming from another vendor or from the cloud services. It can be AWS, Azure, Google, or any other one. I'm using open source. I can find an infrastructure template. It can be a Terraform or a CloudFormation, and I can also get a bunch of services and monitoring capabilities from AWS or anyone. And this is the way that I'm building my application. So it's no longer about writing and developing everything on my own, but mixing and matching from everything that exists in order to reduce my time. So a modern approach to application security would be first legalizing, okay, mixing and matching. I don't want to use everything. Shifting left the security to the first line of code to the first day of the cycle, throughout the cycle in a continuous manner, and under a single stakeholder, which is the developer, that they are responsible for everything that we just discussed, and also the fact that we need as development team to work together with the application security in order to reduce time to security or to have faster time. So AppSec or security in general will not become the bottleneck as they develop their application. And what do developers want? Developers want a kiss, but not a real kiss. They want to keep it simple, okay? And what do they want is also simplicity, okay, right? Keep it simple. They want everything simplified. They don't want to integrate between too many tools. They don't want to switch between the different tools. Remember, we talked about the repository as the center of the universe, and they want one click, they want one trigger, and it can be from anywhere in the cycle. It can be as part of their source control. It can be as part of a pipeline. It can be in a UI. It really depends in their IDEs. And then it triggers the scans to give them a 360 overview of everything that they have in order to better understand the current state of their application and where they need to focus their remediation and where they need to focus their time, because remember, they don't have time to remediate everything. Beside that, it's also about flexibility across the development lifecycle. Why? Because you can do it all. Okay, you can start as early and scan inside the developer IDE. You can be as part of any pull request in your source control management system if you're running on Git, GitLab, GitHub, or any other Azure DevOps, and so on. It can be as part of a CI/CD pipeline, whether you are running a continuous build, nightly, daily, hourly, really depends on the processes that you have. And also as a security check from moving between the different stages, so from testing to development to pre-prod to production to staging, really depends what you have. In order to close the loop, what is also important is the fact that you close the loop and you have an automatic and simplified and seamless integration with your ticketing system. So if a specific issue, whether it's a vulnerability in your open source or something in your application source code, it will open the bug in Jira, send you a Slack message, open a ticket in ServiceNow. So developers, nobody or anybody else will not have to waste time, and it simply become a fact of habit inside your development. And if you are asking me where to start, if you are now starting your cloud native development journey, I suggest to start in the CI/CD pipeline, because it kind of gives you a check from time to time and doesn't bombard you with a lot of information and a lot of noise. So you can have it as part of one of your more stable pipeline and add it there and take it from there all the way to developer ID if it makes sense on every pull request and so on. On the other side, we have CISOs. And what do CISO want? CISO want one thing, two words, risk management. And if they also want to be something special, then they want a simplified risk management. So for them, it's something that will be streamlined. Okay, they want it to be part of the developers ecosystem. They want to lower the total cost of ownership. They don't want to own everything. They don't want to manage too many tools. And also, they want to be the enablers and not the blockers. They don't want their teams or themselves to be the bottlenecks for any development. So they want to be able to enable this digital transformation or cloud native development in a secure manner without losing time, but also with a managed risk. So now that we understand what is a modern AppSec approach to cloud native development, let's talk about the challenges and how we can solve them. So the main change, and we talked about that, is the evolution from monolith into legalizing and mixing and matching everything that exists from third parties or any other cloud vendors. Now, in order to have full coverage of your legalized application, you need to have a bunch of scanners that will cover each part of your application. You need to start probably with a SaaS tool that will statically scan your application source code. You need to have an open source analysis or an SCA, a software composition analysis, as it's called, to make sure that you scan and you don't have any vulnerabilities in your open source. You need to scan your API to make sure that nothing breaks and you don't have any specific vulnerabilities in your APIs, whether they are publicly or privately accessible. You need to scan your infrastructure to make sure that they are configured correctly, meaning your infrastructure as code. You need to scan your containers, both in runtime and their configuration. You need to make sure that you don't have any supply chain, whether through dependencies or any other attack surface that supply chain brings. And Tzachi already elaborated about that. And beside that, you need to have approximately 5 to 6 to 7 different scanners that will be able to cover your entire application. And this is how application security looks today, specifically in light of cloud native development. So as you can see, most AppSec managers say that they have too many tools. They struggle to integrate everything, and they also having a hard time to manage and correlate the risk simply because it comes to or it comes from all those different types of tools. And actually, nobody got time for AppSec, right? Because we need to run fast. The scanners today that I just showed you, each one of them is great, but they lack the context of the wider application. We see what is called now vulnerabilities fatigue or alert fatigue. It means that we are getting too many findings from too many tools, and we are not able to focus on what is important. And also, we don't have time and we don't have the resources because we need to run fast and we don't have the time to remediate everything that we find. And in order to that, in Checkmarks, we introduced exactly 2 weeks ago a new approach that is called Fusion. Fusion is a layer that sits on top of every engine that exists, take different findings, both the findings, the data, and the metadata on each of those findings, and help you and provides you new insightful results to help you. And those results are actionable, prioritized, and meaningful, so you can focus exactly on what you need. So what is Fusion? Fusion is the process actually that powers the sun and the stars, if you didn't know. It's actually the reaction that takes two different atoms and combine them together, creates a new atom of helium. So if you take two hydrogen atoms, combine them together, this is the process that creates helium. And on the same manner, this is exactly what we are doing. And this is how we can help you focus on what is important. And what we are doing is that we are fusing the results together, which helps you provide context from one engine, from one scanner to the other, help you and help your developers focus on the most critical aspects of your application, provide you new insights in the matter of either visualization or textual insights in your application, and also make sure that your entire cloud native stack is measured, it's mapped, and is fully covered with everything that you need from an application security point of view. So how does it look and how does it work? By correlating different findings from SAS, the static application scanning, together with infrastructure as code, we can take and we can build you this interactive map or interactive topology of your application based on all the information that is coming from your repository. So we scan your application source code, finds all the different microservices, correlate them with the cloud resources that we can scan from scanning your infrastructure as code, and telling you exactly which microservice is using which cloud resources, and also helping you find exactly the most important areas in your application. So if your application, your cloud native application was a bomb, we help you diffuse it, and in a matter of seconds and not hours. What we do is we help you pinpoint the weakness in your application. As you can see here, we have an S3 bucket that is connected to 3 different microservices, and also help you identify the problematic, because this S3 bucket that we were able to find from scanning your infrastructure as code has public access and has 3 different microservices that are writing to that. So in case you have an SQL injection in one of those API, it's probably more important to focus on fixing this specific weak point in your application than any other area of the application. And then we allow you to isolate the area of the application and remediate specific this area. So if you have 5 minutes to remediate your application, you will know exactly where you want to work on and what to remediate, so you can focus on what matters most, because you don't have time to work on everything. You don't have time to remediate on everything that exists. Okay, so to recap, because we covered a lot of ground over the last 20 minutes, we talked about what are the challenges of cloud native development, the business need for speed, running faster than ever, all the challenges, the responsibilities that lies on the developer, and the fact that a single change can reach production within a matter of minutes. We talked about a modern AppSec approach to cloud native and the fact that we want it simplified, right? Developers want a KISS, keep it simple, and also finished with what are the challenges and the fact that all of those scanners scan in a silo manner, and we want to find a way that will gather all the information together so you can see an holistic view. And if you only have 5 minutes to remediate your application, you will know exactly where you want to focus on. And this is specifically why we at Checkmarks created Fusion, which helps you find and identify and isolate all of the issues in your application. And with that, I'd like to thank you for your time listening to me today. And remember, the world run on code, and we at Checkmarks secure it. Thank you very much.